All right, welcome to our class today. Unfortunately, I can't be with you today. So what we're going to do is we're gonna go through the um 17b reciprocal function. Let me just make it a little bit bigger. Much better. So with reciprocal function, you need to distinguish that between the inverse function. The inverse function is we switching the place of x and y. If we say a function is y equals to fx, then inverse function will be x equals to fy. I mean the inverse. For reciprocal function, however, it's a little bit different. So if you have something like y equals to 1, oh, come on, 1 over, sorry, x, or x to the power of something, then after reciprocal, it actually became y equal to 1 over x. So the idea is flipping it. And when we see the image of something being flipped, we will have more idea about, in general speaking, how do we collect all those similar graph into, we can find some rules on the reciprocal functions. So let's say, for example, if we start with sketching the graph of y equals to x to the power of 3. So I think we studied that in methods before. So y to the power, sorry, x to the power of 3, y is equal to x to the power of 3. We can start from here. The whole graph look like this, and it's gonna go down this way as well. Now there are something that's gonna stand out for us in the beginning. For example, there is one key point, and the key point will be in between 0 and 0. So when we have x equal to 0, now x to the power 3 is equal to 0, so y in this case is equal to 0. In contrast, what happened to y equal to 1 over x to the power 3? Well, if we have the same thing, so when x equal to 0, x to the power 3 is equal to 0, then y will be equal to 1 over 0. Now, 1 over 0 in math is you are breaking it. You can't do it. So that is actually undefined. How do I draw undefined? I draw asymptotes. Okay, so which means this will be an asymptote where x equals to 0, and the graph will never cross it. It will get infinitely close to it, but it wouldn't cross it. When we have the asymptotes, it do give you two information. If you just hear what I said, the graph shouldn't cross it, and the graph should get really close to it. So it give you an idea about a graph is merging towards x equal to 0 to that line in here. So what's the actual graph look like? Well, we can, try some numbers and we can see it. For example, in here, when x equal to 1, y is equal to 1. Now, if you're flipping it, let me just change the thing back. When x equal to 1, y should be equal to 1 to the power 3, which is equal to 1. So that's y should go across here. And if we have the reciprocal function when x equal to 1, y is 1 over 1 is also equal to 1, which makes sense. Now, when we have something like when x equals to 2, y will be equal to 2 to the power 3, which will be equal to 8. Now, unfortunately, I don't think I can draw the 8 out there. I can't draw the 8 out there. It's beyond the graph. But I can do the reciprocal. So let's say when x equal to 2, y will be equals to 1 over 2 to the power 3, which is equal to 1 over 8. So it will be much more lower than 1. So it will be somewhere around here. If you picturize a graph, it's merging towards the asymptote. It have to cross those 2 points. you kind of like naturally saying, I kind of can picturize a graph in, oops, sorry. I kind of like can picture a graph in this direction. Can you see that? Should be in this direction. Now, the second question you may want to ask yourself is, can we have y equal to 0? When I say y equals 0, that means can we cross the x-axis? The answer is no, because since x can never be 0, 1 over something, 1 over a non-zero number, cannot be 0, and 1 over 0 will be undefined. So we will have two asymptotes in here, which means here we have y equal to 0 is also an asymptote. And likewise, we can do the similar thing for the negative quadrant as well. So which means they will share a point in here. The general trend is this. Okay. All right. Um, so here show you an idea about a key point. Okay. I hopefully you can see how we approach this question is you starting from a key point. You always want to start from there. And in this case, the key point or the important point or the important feature, blah, 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 the key point for this question will be the x-axis intercept. Let me draw it in this color. X-intercept. Okay, because the original points go through here. So once you flipping it, the key point became something else. Now, later on in 17C, we're gonna summarize all the key informations on how we approaching the line and how we draw the graph. And we can do the summarizing here, but you can kind of like see a trend where when we growing in x in the reciprocal, we actually have decreasing in x in the x value when we when we growing in x value in this direction, we'll have, if we have increasing trend in y in the original graph, then we'll have a decreasing trend in y in the reciprocal graph. I also have another method called spaghetti methods. Spaghetti methods is basically you picturize the original graph like a string of spaghetti. Say this is the original graph. And what you're going to do is you're going to break the spaghetti at the x-intercept and you're going to basically flipping them. So you have to be creative on thinking. You're flipping them across these two axes. All right. Now you're flipping here towards here and this one towards here. Here towards here and this place towards here. When I see you on Thursday, I'll show you, hopefully I can bring some spaghetti or noodles and I can show you in person and what that means. Okay, now let's go on to the next one. We have a function and sketch the graph, original graph, and then the inverse function on the same set of the axis. Do we have given an axis? Yeah, we have it in here. We also have it in here, so great. Let's try to sketch it. So x squared plus 2, so which means we have x squared and then we move vertically up for 2 units. We'll have the graph go from here. I'm just gonna randomly draw it. Don't look at the actual coordinates, so but the general trend of the graph should look like this. Okay. Then what will be the reciprocal graph? What does it look like? Well, in here we have a second scenario where we don't really have an x-intercept. Then what will be some key feature we can rely on? Well, any key feature, if you learn from year 10 or in year 11 math method, you will know that turning point will be a key feature. So let's look at the turning points. Turning point is where x equal to 0, y is equals to 2. So if I do the reciprocal of 2, I will have 1 over 2. So let me just write in here. We have x equal to 0, y is equal to 0 plus 2 is equal to 2. Likewise, when x equal to 0, 1 over y will be equals to 1 over 2. So we'll have 1 over 2 in here, halfway. Okay, 0 and 1 over 2 in here. And then what will be the trend of the graph? As we see from the last graph in here, where we having the spaghetti, we flipping them, and we can kind of like see a rough trend in here as well. If you can't see the trend now, you could sub in that some of the numbers, but I'll try to show you the trend. So the trend is, let me use darker color in here. When x go moving along this axis, the y value was decreasing for this graph. You can see from here, the value is steadily decreasing. So which means on the reciprocal where we have 1 over that, the y value should be increasing over this interval. So I'll have from here all the way towards the up in here. Again, why do we not crossing the x-axis? Is we dealing with 1 over y. Okay, we're dealing with 1 over y. And since x is non-zero number, so we don't really have a, we can't reach to 0. So which means our asymptote in this case will be y all equals to 0. This also correlates to what we talked about before in the last question. If we have an vertical asymptote, we should have a x-intercept. But in here, we don't have an x-intercept in the original graph. Sorry, in the original graph, we don't have an x-intercept. So which result in the reciprocal graph, we don't really have a vertical asymptote. Now, the general trend for this way is when we have increasing in the x values, we have the y value is constantly increasing. So in the reciprocal graph, we're gonna have decreasing in this. With the spaghetti methods, I will say here's the original graph. Now the maximum became minimum, and I'm simply pushing the spaghetti down, pushing it down, something like that. But since we don't really have an x-intercept, we are having no vertical asymptote, so you don't actually break the spaghetti. Okay. All right, next one. The original graph is 2x take away 1, x plus 1. So the original graph intercepts at x equal to 1, x equal to -1. They're here. The y-axis is when x equals to 0. -1 plus multiplied by 1 is -1. And multiplied by 2 is -2. So the original graph should look something like this. Don't worry about the coordinates beyond the x and y intercepts, because I really not sure. I just randomly draw one. And to find out the reciprocal graph, again, we can analyze the key points. Now we have both key points. We have a turning point. We also have the x-axis intercept. So the x-intercept, Why am I doing this color? Let me change it back to the original color. Um, so those key points in the reciprocal graph, they're gonna become vertical asymptote, and the maximum turning point will become the minimum turning point. Okay, so we could start drawing the graph by labeling the asymptotes. And those two asymptotes are, we have x equal to -1, x equals to 1. And then along the graph, when x is increasing, y is decreasing. So the reciprocal graph is when x is increasing, y should be increasing, and it's approaching the asymptote. So we should have something roughly in here. We're not intercepting the y-axis because we're dealing with 1 over something. All right, 1 over. In the same reason, let's deal with this hand side first. Okay, so when we have x increasing, y is increasing for the original graph. So for the reciprocal graph, we have when x increasing, y should be decreasing. So we have this. Now, for the bottom section, we have something interesting. We could calculate the minimum turning point by, this one is -2, so 1 over -2 is -1 over 2, so it should be somewhere in here. And you could you use the when x increasing, y should be original graph is decreasing, so the reciprocal graph is increasing. And likewise, on the other hand side, you could find some similar conclusions. So you will see a nice graph in here and flipping it down. If you want to refer to the spaghetti method, once you figure out the key points, so which are here, here as the x-intercept, here as the turning point, and then you break the spaghetti. You didn't break it from here, remember, because that's not the x-intercept. And then you simply flipping them. You do need to calculate the turning point because this is something you could calculate. So let me just label it on here. All right. And I think that's it for today. So next lesson, we're going to work on 17C. If you have done the questions in 17B, and if you want to have a look on 17C, you should be able to do it. You should be able to do some question in here as well, but we can talk more about spaghetti. Hopefully I can bring a spaghetti in the class next lesson. And if you have any question, you could ask me, you could message me, you could ask your teacher as well. And yeah, I'll see you guys next lesson. All right.